Developer tooling used to feel like the safe part of the system. Production was the scary place. The database, the cluster, the load balancer, the pager. And then everything around that was just tooling. GitHub, CI CD, merge queues, package publishing, code review bots, AI agents. But that line is getting harder to defend because when the tooling can merge code, publish artifacts, leak secrets, spend money, or decide what gets shipped, it is not just sitting beside production anymore. It is part of production. And this week, that idea showed up everywhere. Hey, I'm Brian Teller. I work in DevOps and SRE, and I run Teller's Tech. This is Ship It Weekly, where I filter the noise and focus on what actually changes how we run infrastructure and own reliability. Show notes and links are on shipitweekly.fm. If this show's been useful, follow it wherever you listen. Ratings help way more than they should. And if you are watching on YouTube, subscribe there too. We have 6 main stories today, then the lightning round, and we'll wrap with the human closer. We're starting with GitHub's critical Git push remote code execution vulnerability, including the AI reverse engineering angle from Wiz. Then we'll talk about prompt injection against AI agents tied into GitHub workflows. After that, Elementary's CLI supply chain incident, where a GitHub Actions workflow became the path to a malicious release. Then GitHub's April 23rd merge queue regression. Then cal.com going closed source, which is probably the most argument-starting story in this set. And finally, GitHub Copilot moving to usage-based billing because AI tooling is becoming a governance and cost management problem, not just a productivity experiment. Then in the lightning, we'll hit MinIO, Ghostty, Docker Hardened Images, and Azure DevOps security updates. Story 1. GitHub's Git push RCE is a toolchain wake-up call. Let's start with GitHub. GitHub disclosed a remote code execution vulnerability in the Git push pipeline. The issue affected GitHub.com, GitHub Enterprise Cloud, GitHub Enterprise Cloud with data residency, Enterprise managed users, and GitHub Enterprise Server. GitHub says Wiz reported the bug through the bug bounty program on March 4th. GitHub reproduced it internally within about 40 minutes, fixed GitHub.com in under 2 hours, and says it found no evidence of exploitation. That is the reassuring part. The uncomfortable part is the shape of the bug. The vulnerability involved user-supplied Git push options. Those push options ended up influencing internal metadata passed between GitHub services. Because of how that metadata was formatted, an attacker could inject extra fields that a downstream service treated as trusted internal data. And once user input can shape trusted internal metadata, things get ugly fast. GitHub says the researchers showed they could override the environment where the push was processed, bypassing sandboxing around hook execution, and ultimately execute arbitrary commands on the server handling the push. That is a lot hiding behind the phrase git push. And that is why this belongs in a DevOps and SRE conversation, not just a security newsletter. Every team treats Git as normal plumbing. Humans push code. Bots push code. Automation responds to pushes. CI kicks off. Release workflows start. Security scanners run. Deployment paths wake up. But behind that one command is a hosting platform, internal service boundaries, hook execution, sandboxing, audit logs, and identity. That is infrastructure. For GitHub.com and Enterprise Cloud users, GitHub says the platform was patched and no customer action is needed. For GitHub Enterprise Server customers, this is a patch now situation. GitHub specifically recommends upgrading supported GHES releases and reviewing audit logs for suspicious push operations. But the bigger story may be how Wiz found it. Dark Reading covered the AI-assisted reverse engineering side. Wiz used AI tooling to help analyze GitHub Enterprise Server, understand compiled binaries and internal service behavior, and find a bug that historically may have taken weeks or months to uncover. They reportedly went from the idea to working exploit in under 48 hours. That is the part that should stick with us. Not because AI found a bug, like the robot woke up and became a hacker. The real story is that AI lowered the cost of understanding complex systems. A lot of software has been protected informally by being annoying, hard to reverse engineer, hard to understand, too much glue, too many binaries, too many internal assumptions. That was never real security, but it was friction. And friction matters. If AI removes enough of that friction, then systems that were probably fine because nobody will spend the time become more interesting targets. So the takeaway is not panic. It is that boring security engineering matters more when discovery gets faster. Input validation, trust boundaries, least privilege, patch velocity, audibility. Because when the cost of finding bugs drop, the cost of sloppy assumptions go up. Story 2. Prompt injection is now in the CI/CD blast radius. Next up, AI agents and GitHub Actions. The register covered research showing prompt injection attacks against AI agents from Anthropic, Google, and Microsoft, tied to GitHub workflows. The basic shape is pretty simple. AI agents read GitHub data, pull request titles, issue bodies, issue comments, review comments, markdown, the stuff developers and contributors write all day. So, if an attacker can place malicious instructions into that data and an agent later processes it with access to tools or secrets, the attacker may be able to steer the agent. In the Claude case, researchers showed that a malicious PR title could influence the bot and leak credentials into a review comment. With Gemini, issue comments and prompt injection were used to expose an API key. With GitHub Copilot agent, malicious instructions could be hidden in an HTML comment that humans would not see in rendered markdown. The victim assigns the issue to Copilot, but the payload is already sitting there in the context. The researchers demonstrated theft of Anthropic and Gemini API keys, multiple GitHub tokens, and potentially any secret exposed to the GitHub Actions runner environment. That last phrase is the one I care about, the GitHub Actions runner environment. Because this is not just an AI story. This is a CI/CD story. If your agent runs in GitHub Actions and GitHub Actions has access to tokens, deployment credentials, package publishing rights, cloud permissions, Slack webhooks, or Jira credentials, then prompt injection becomes part of that blast radius. The researcher called this comment and control, which is a play on command and control. And it fits. The attacker may not need malware. They may not need an external callback. They may not need to trick a human into clicking anything. They can write data into GitHub, let automation read it, and let the automation leak the secret back into GitHub. That is a nasty little loop. And this is where I think teams are a little too cautious about agents. A code review bot should not have more access than it needs. An issue summarizer should not have repository write access. A documentation bot does not need cloud keys. And if you are passing untrusted GitHub content into an agent that can use tools, run commands, or read secrets, that is not a harmless productivity flow. That is untrusted input hitting an execution environment. We have had that category of problem for decades. AI did not invent it. AI just made the parser weird. Story 3. Elementary's CLI incident is the supply chain story in miniature. Now let's talk about Elementary. Elementary Data published a security incident report for a malicious release of the Elementary open source Python CLI version 0.23.3. On April 24th, a malicious CLI package was published to PyPI, and a malicious Docker image was published to their registry. Those artifacts were not produced by the Elementary team. According to Elementary, the attacker opened a PR with malicious code and exploited a script injection vulnerability in one of their GitHub Actions workflows to publish the release. That is the modern supply chain anxiety loop in one story: a pull request, a workflow vulnerability, a release-looking artifact, PyPI, Docker, and downstream users who now have to assume any credentials accessible to the environment where that CLI ran may have been exposed. Elementary removed the malicious release, published a safe 0.23.4, removed the vulnerable workflow, rotated affected credentials, and moved the OIDC authentication where possible. That response sounds pretty solid, but the attack path is the real lesson. A lot of teams still think of GitHub Actions as a convenience layer. But for many projects, GitHub Actions is the release authority. It builds containers. It publishes packages. It signs things. It pushes to registries. It decides what gets shipped. So if that workflow has script injection, broad permissions, long-lived tokens, or too much trust in PR-controlled input, then your release system can become the attack path. The question is not only, do you trust your source code? It is also, do you trust the automation that turns source code into artifacts? Those are not the same question anymore. You can have a clean main branch and a vulnerable release workflow. You can have signed releases and a compromised signing path. You can rotate app credentials and still forget that the package publisher token has been sitting in CI forever. So the practical playbook is boring but important. Check workflow permissions. Avoid long-lived publishing tokens where OIDC is available. Be careful with shell interpolation from PR titles, branch names, issue comments, tags, and commit messages. Split build and publish. Protect release environments. And threat model GitHub Actions like production. Because if GitHub Actions can publish your package, it is production. It might not serve customer traffic, but it controls customer trust. Story 4. GitHub's merge queue regression is a control plane reliability story. Next one is also GitHub, but from a reliability angle. On April 23rd, GitHub had a merge queue regression. GitHub says pull requests merged through merge queue using squash merge produced incorrect merge commits when a merge group contained more than one pull request. In some affected cases, changes from previously merged PRs and prior commits were accidentally reverted by later merges. GitHub says that 658 repositories and 2,092 pull requests were affected. No data was lost because the commits still existed in Git, but affected default branches ended up in an incorrect state, and GitHub could not safely repair every repository automatically. That is a painful incident. And it is painful because merge queues exist to reduce risk. That is the whole point. They are supposed to make high change environments safer. Instead of everyone racing to merge against a moving base branch, the queue group changes, validates them, and lands them in a more orderly way. So when that control plane gets a bad behavior, it creates a weird kind of incident. Not the site is down, not the database is corrupted, but the mechanism we trust to preserve correctness just produced a branch state that is not what we think it is. That is subtle. And subtle is dangerous, because if a deploy fails loudly, you know. If an API goes red, you know. If a merge queue quietly reverts earlier changes, you might not notice until the wrong code is already in production. The practical takeaway is not don't use merge queues. I still like merge queues. The takeaway is that any environment with merge authority needs SRE thinking, good audit trails, easy ways to identify what changed, detection when a branch state does something weird, clear ownership when the thing that protects main becomes the thing that damages main, merge queues, feature flag systems, CI schedulers, artifact registries, deployment orchestrators, GitOps controllers. These are control planes. They may not be in the request path, but they shape what production becomes. Story 5. Cal.com going closed source is the argument everyone will want to have. Now for the spicy one. Cal.com announced that it is going closed source. They said that after 5 years as open source champions, they are moving the production codebase closed because AI has changed the security landscape. Their argument is basically this. In the past, exploiting an application required skilled humans, time, and patience. Now AI can be pointed at an open source codebase and used to systematically scan for vulnerabilities. Cal.com says that being open source is increasingly like giving attackers the blueprints to the vault. They are keeping an open version available as cal.diy under the MIT license. But they say that the production cal.com codebase has diverged, including rewrites in areas like authentication and data handling. I have mixed feelings on this one. On one hand, I understand the concern. This week's GitHub and Wiz story gives some support to the idea that AI can make vulnerability discovery faster and cheaper. If you run a SaaS product handling sensitive calendar data, authentication flows, integrations, and customer information, it is not crazy to worry about AI assisted vulnerability mining. On the other hand, closed source equals safer is not a clean argument. Closed source software still gets reversed. Closed source software still has bugs. Closed source software can lose the benefit of external review. And hiding code is not the same as securing it. So I would not frame this as cal.com is right or cal.com is wrong. The better framing is that AI is putting real pressure on the business and security model of commercial open source. For maintainers, open source can mean transparency, community, contributions, and trust. For customers, it can mean self hosting, auditability, and less vendor lock in. For attackers, it can mean a searchable map of the systems. And for a commercial company, it may mean all of those things at once, plus support burden, vulnerability reports, hosted customer risk, and investor pressure. That tension is not new. AI just makes it louder. For platform teams, the takeaway is not stop using open source. That would be ridiculous. The takeaway is stop treating project governance and licensing as background noise. When a project changes its source model, repo model, release model, or commercial posture, that is supply chain signal. You do not have to panic, but you should notice. Story 6. Copilot usage-based billing makes AI a governance problem. Last main story. GitHub Copilot is moving to usage-based billing on June 1st. GitHub says all Copilot plans will transition to GitHub AI credits. Instead of counting premium requests, plans will include a monthly credit allotment, and usage will be calculated based on token consumption, including input, output, and cached tokens. Base subscription prices are not changing, according to GitHub. Code completions and next edit suggestions stay included. But agentic usage, longer sessions, heavier models, and multi-step workflows move more directly into the cost model. And one detail jumped out at me. Copilot code review will also consume GitHub Actions minutes in addition to GitHub AI credits. That is what makes this a platform engineering story, because now AI usage is not just a seat cost. It is tokens, model choice, cached context, review automation, actions minutes, budget controls, and admin visibility. And this is the normal cloud story happening again. First, it feels magical. Then everyone adopts it. Then the bill shows up. Then leadership asks, why is it growing? Then teams discover they do not have tagging, budgets, ownership, quotas, or usage visibility. Then platform teams get asked to govern it after it is already everywhere. We saw this with cloud. We saw it with observability. We saw it with CI minutes. Now we are going to see it with AI assisted development. I am not anti Copilot. I use AI tools constantly. But the economics are changing. A quick autocomplete suggestion and a multi-hour agentic coding session are not the same cost profile. A lightweight code explanation and a repo-wide refactor are not the same cost profile. A human asking a few questions and an agent iterating across a codebase are not the same cost profile. GitHub is saying that more directly now. And teams should probably take the hint. If AI behaves like cloud spend, you need cloud spend habits, visibility, ownership, guardrails, budgets, and somebody who notices before the bill becomes the incident. A few quick ones before we wrap. MinIO's main GitHub repo was archived by the owner on April 25th and is now read-only. The README says the repository is no longer maintained and points users towards other options. It also says that the Community Edition is now source-only and that legacy precompiled binaries will not receive updates. That is a big dependency signal if you have MinIO in your stack. Ghostty is leaving GitHub. Mitchell Hashimoto wrote that Ghostty plans to move off of GitHub while keeping a read-only mirror at the current URL. The interesting part is his framing. He says the problem is not Git itself. The problem is the surrounding infrastructure that people rely on. Issues, pull requests, actions, and platform workflows. Git may be distributed, but your actual engineering workflow usually is not. Docker published a one-year reflection on Docker Hardened Images. They say Docker hardened images crossed 500,000 daily pulls, with more than 2,000 hardened images, MCP servers, Helm charts, and ELS images. That is a nice counterweight to the rest of the episode. Not every supply chain story is a compromise. Some of the work is making safer defaults easier to adopt. Azure DevOps added one-click code QL setup and org-wide alert triage to advanced security. Microsoft says teams can enable code scanning at the repo, project, or organization level without manually configuring a pipeline, and security admins get a combined alerts view across repositories. Not super flashy, but useful when security has to scale beyond fixing repo number 417 by hand. I think the human thread this week is that engineers are still emotionally treating developer tooling like it lives outside the blast radius. And it does not. The build system is not outside the blast radius. The merge queue is not outside the blast radius. The package publisher is not outside the blast radius. The AI review bot is not outside the blast radius. GitHub Actions is not outside the blast radius. Copilot billing is not outside the governance conversation. The open source project that you depend on is not outside your supply chain just because you started the repo 5 years ago. All of this is part of production now. Maybe not production in the narrow sense, maybe not serving customer traffic at this exact second, but production in the operational sense. If this breaks, we cannot ship. If this is compromised, customers may be affected. If this gets expensive, leadership will care. If this silently does the wrong thing, production may become wrong later. If this changes its licensing or maintenance model, our roadmap may get weird. That is production. And I think that shift is hard because developer tooling used to feel like the comfortable part of engineering. It was where we moved fast, where we automated things, where we glued things together with tokens and YAML and a little bit of we'll clean this up later. But the shortcut became the path, and the path became the control plane. And the control plane now has secrets, merge authority, release authority, billing impact, AI behavior, and platform dependency risk. That does not mean every team needs to panic. It means we need clearer labels. A GitHub Actions workflow that publishes to PyPI is not just CI. It is a release system. A merge queue that lands code on main is not just a productivity feature. It is a source control plane. An AI agent with repo access and secrets is not just a bot. It is a principal with tools. An open source dependency whose repo gets archived is not something to look at later. It is a dependency management event. And a Copilot billing change is not just pricing. It is a governance signal. Once you label the system correctly, you can manage it correctly. You can put the right permissions around it. You can monitor it. You can budget for it. You can patch it. You can separate trusted and untrusted input. You can stop pretending that the thing with keys to production is somehow not production. Reliability is not just keeping servers up. It is keeping the paths to production trustworthy. And this week, those paths looked a little more serious than usual. All right, that's it for this week of Ship It Weekly. Quick recap. GitHub patched a critical git push remote code execution vulnerability. And the AI assisted reverse engineering angle may be just as important as the bug itself. Researchers showed prompt injection attacks against AI agents tied into GitHub workflows, which is a pretty clear reminder that agents are now in this CI CD blast radius. Elementary data dealt with a malicious CLI release published through a vulnerable GitHub Actions workflow. GitHub had a merge queue regression that affected more than 600 repositories and more than 2,000 pull requests. Cal.com is going closed source and putting a spotlight on the tension between AI, security, open source, and business models. And GitHub Copilot is moving towards usage-based billing, which means AI tooling is becoming a cost and governance conversation, not just a productivity conversation. Then in the lightning round, we hit MinIO archiving its main repository, Ghostty leaving GitHub, Docker hardening images crossing 500,000 daily pulls, and Azure DevOps making code QL setup and org-wide alert triage easier. Links and show notes are on shipitweekly.fm. You can also find the video version on YouTube. If this episode was useful, send it to the person on your team who still says it's just CI. I'm Brian, and I'll see you next week.